Hey you guys, this is Mr. Millings, and in this video we are going to go over some medium level Lewis structures. So in an earlier video we learned how to draw the Lewis structures for fairly simple compounds and molecules, and in this video we are going to expand that and we are going to draw the Lewis structures for more challenging molecules or compounds. So in this first example, it says to draw the Lewis structure for carbon dioxide. So we know that the chemical formula for carbon dioxide is CO2. And what we have to do now is we have to figure out how many valence electrons this little molecule has. So we know that carbon has 4 valence electrons. We know that oxygen has 6 valence electrons, but there are 2 oxygen atoms in this molecule. So when we add this together, we're going to end up with 16 valence electrons, or 16 electrons that we're going to have to spread around these 3 atoms here, satisfying the octet rule for each one of these atoms. And so if we take a look, which of these atoms is going to be our central atom, carbon or oxygen? Well, carbon is the least electronegative atom of these two, so carbon is going to be at the center. We know that carbon is bonded to oxygen, and it's bonded to oxygen here, right? There's 2 of them. So how many electrons have we just used up drawing these 2 bonds right here? Well, we have 2 electrons here and we have 2 electrons here. So we've just used up 4 electrons, which leaves us with 12 electrons that we will have to spread amongst these atoms here, satisfying the octet rule for each one of these atoms. So let's go ahead and try this out. We have 12 valence electrons. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and 12. Let's see if this works. So if we take a look, we've used all 16 valence electrons, 2, 4, 6, 8, 10, 12, 14, 16 valence electrons. This oxygen has 2, 4, 6, 8 surrounding it. This oxygen has 2, 4, 6, 8 surrounding it. But take a look at this carbon. This carbon here only has 2, 4 valence electrons surrounding it. So this cannot be the correct Lewis structure for CO2, because not every single atom satisfies the octet rule. So what can we do here? What can we do to ensure that every single atom here has 8 valence electrons surrounding it? So this is the incorrect Lewis structure. So what can we do? Well, let's play around with this. What if we do this? What if we put carbon at the center, we bond it to oxygen here, and we bond it to oxygen here? So we've just used up 4 of our valence electrons, 2 here and 2 here, which leaves us with 12 left over. But what if we do this? What if we put 1, 2, 3, 4, 1, 2, 3, 4 valence electrons surrounding each one of these oxygens, and we give a double bond between each carbon and oxygen? Let's see if this works. Let's see, this oxygen now has 2, 4, 6, 8 electrons surrounding it. This oxygen has 2, 4, 6, 8. Keep in mind, a bond counts as 2 valence electrons. And this carbon now has 2, 4, 6, 8 valence electrons surrounding it. And so every one of these atoms now has 8 valence electrons surrounding it. And have we used only 16 electrons total? We have 2, 4, 6, 8, 10, 12, 14, and 16 valence electrons that are now surrounding all of these atoms here. And so this is going to be the correct Lewis structure for CO2, right? This is going to be the correct Lewis structure for CO2. And anytime we have 2 pairs of electrons that are being shared between atoms, the result is going to be a double bond. So we have a double bond here between carbon and oxygen, and we have a double bond here between our carbon and oxygen. And so CO2 contains two double bonds between the carbon and oxygen, as we see in this picture right here. Alright, so understand that concept that we have two pairs of electrons that are being shared between each carbon and oxygen. Let's take a look at another example. In this second example, it says to draw the Lewis structure for nitrogen gas. So nitrogen gas, what is nitrogen gas? Well, nitrogen gas is N2, right? It's one of the diatomic molecules. And so we have to figure out how many valence electrons there are total in nitrogen gas, or N2. So we know nitrogen has 5 valence electrons based on its position on the periodic table of elements. But there are 2 nitrogens, so we're going to multiply this by 2, and this is going to give us 10 valence electrons that we need to place around these 2 nitrogens, satisfying the octet rule for each one of these nitrogens. So let's go ahead and do that. First of all, we know that nitrogen is going to be bonded to nitrogen. So we've just used up 2 valence electrons here in our bond between the 2 nitrogen atoms, and so that leaves us with 8 valence electrons that we have to surround these nitrogen atoms, satisfying the octet rule for each one of these nitrogens. So here we go, 1, 2, 3, 4, 5, 6, 7, 8. And you say to yourself, okay, I'm done. Well, let's take a look at this. We've used 2, 4, 6, 8, 10 valence electrons. But does each nitrogen have 8 valence electrons surrounding it? This nitrogen here only has 2, 4, 6. This nitrogen here only has 2, 4, 6. So this is wrong. This is the incorrect Lewis structure for nitrogen gas. So let's try this again. So you say to yourself, okay, maybe what I need is a double bond between these. So I've used up 4 valence electrons. 10 minus 4 is 6. Okay, so 1, 2, 3, 4, 5, 6. Okay, here's my Lewis structure. Well, let's take a look. We've used all 10 valence electrons, 2, 4, 6, 8, 10. This nitrogen has 2, 4, 6, 8 surrounding it. So it's happy. This nitrogen, though, only has 2, 4, 6 surrounding it. So this is going to be incorrect as well. So what can we do to satisfy the octet rule for each one of these nitrogens, meanwhile only using the 10 valence electrons that we have right here? You guessed it, we're going to have to draw a triple bond between the 2 nitrogen atoms. So we've just used up 2, 4, 6 of our valence electrons. Keep in mind a bond always counts as a pair of electrons, so we have 2, 4, 6 here. And when we take 10 minus 6, we're going to have 4 valence electrons left over. So we're going to put 2 right here and 2 right here. And you might wonder why I'm putting these 2 electrons on the sides instead of up top here. Well, electrons are negative. These guys are negative, and they like to repel each other to the furthest possible distances from one another. So if they repel each other to the furthest possible distance, these pairs of electrons here will actually be on the sides of our nitrogen atoms in this Lewis structure. So if we take a look, we've used 2, 4, 6, 8, 10 valence electrons. We only had 10. And if we take a look, this nitrogen has 2, 4, 6, 8 surrounding it. This nitrogen has 2, 4, 6, 8 surrounding it. So this is going to be the correct Lewis structure for nitrogen gas. So this is our correct Lewis structure. And if we take a look here, what do we have in between these 2 nitrogen atoms? Well, we have 3 pairs of electrons being shared. And whenever you have 3 pairs of electrons being shared, the result is a triple bond. So nitrogen gas has a triple bond. Let's take a look at another example. In this third example, it says to draw the Lewis structure for oxygen gas. So oxygen gas is diatomic. We know oxygen gas is O2. And we know that oxygen has 6 valence electrons, but we have 2 oxygens here. So we have a total of 12 valence electrons. And so we know that oxygen is going to be bonded to oxygen, so we've just used up 2 electrons. So that's going to leave us 10 valence electrons to spread around these oxygens here, satisfying the octet rule for each one of these. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've just used up the remaining 10 electrons. This oxygen now has 2, 4, 6, 8 surrounding it, so it's happy. But this oxygen here only has 2, 4, 6 surrounding it. So we can't just simply add 2 more electrons because we'd be using more than the 12 electrons that oxygen has. So this is the incorrect Lewis structure for O2. So how can we draw the correct Lewis structure for O2? Well, let's take a look. If we have oxygen double bonded to another oxygen with electrons like this, keep in mind that electrons are negative and they're going to want to repel each other to the furthest possible distance. Let's take a look. We've used 2, 4, 6, 8, 10, 12 valence electrons here. And we'll notice that each oxygen atom has 2, 4, 6, 8 surrounding it. This oxygen has 2, 4, 6, 8 surrounding it. So we've used all 12 valence electrons and satisfied the octet rule for each one of these oxygen atoms. So this is going to be the correct Lewis structure for oxygen gas. And if we take a look between each one of these oxygens here, we have 2 pairs of electrons being shared and a double bond is formed between them. Let's take a look at another example. In this 4th example, it says to draw the Lewis structure for cyanide. So we have cyanide. Cyanide is Cn-. It's a polyatomic ion. So this carbon atom has 4 valence electrons. This nitrogen here has 5 valence electrons. And this negative sign here means that this group of atoms here has 1 extra electron, and that is why it is negative. So we're going to add 1 to this. So we have a total of 10 valence electrons to use to satisfy the octet rules for carbon and nitrogen. And so let's go ahead and try this out. We have carbon bonded to nitrogen. So we've just used up 2 of our valence electrons, and that is going to leave us with 8 electrons left over to surround carbon and nitrogen, satisfying the octet rule for each one of these. So here's 2, here's 4, here's 6, and here's 8. So let's take a look at this. Whenever we have a polyatomic ion or an ion, a monatomic ion, an atom with a charge or a group of atoms with a charge, and we're asked to draw the Lewis structure, we always have to put brackets around the Lewis structure and then indicate the charge. So let's see if this is right now. If we take a look, we've used 2, 4, 6, 8, 10 of our valence electrons here. This carbon atom only has 2, 4, 6 electrons surrounding it though, and this this nitrogen has 2, 4, 6, and this carbon only has 2, 4, 6 electrons surrounding it. So this is going to be the incorrect Lewis structure for cyanide. So let's go ahead and try this over again. What if we put a double bond between our carbon and our nitrogen? We've just used up 2, 4 valence electrons. 10 minus 4 is 6 electrons left over. 1, 2, 3, 4, 5, 6. Is this going to end up working? Well, let's take a look. If we take a look at our nitrogen, we have 2, 4, 6, 8 surrounding it, so it's happy, but this carbon here only has 2, 4, 6 electrons surrounding it. So this is incorrect, right? We've used all 10 of our electrons, 2, 4, 6, 8, 10, but this nitrogen has, this nitrogen has 8 and this carbon only has 6 surrounding it. So this 2 would be incorrect. So what can we do to draw the correct Lewis structure here, satisfying the octet rule for each one of these atoms and only using 10 valence electrons? You guessed it, we're going to have to put a triple bond between carbon and nitrogen here. We've just used up 2, 4, 6 electrons. 10 minus 6 is 4. There's 4 valence electrons left over. 2 right here and 2 right here. Let's put the brackets around this. Let's indicate the charge and let's see if this works. We've used 2, 4, 6, 8, 10 valence electrons. This nitrogen has 2, 4, 6, 8. This carbon has 2, 4, 6, 8. So, looks good. This is going to be the correct Lewis structure for cyanide. And as we see right here, there's going to be a triple bond between our carbon and nitrogen atoms in cyanide. Let's take a look at one final example. In this final example, it says to draw the Lewis structure for nitrate, or NO3-. So we have NO3 with a minus charge, our nitrate polyatomic ion. Nitrogen has 5 valence electrons. We know that oxygen has 6 valence electrons, but there's 3 of them. And then what does this minus sign mean to do? It means there's an extra electron, and so we're going to have to add 1 to this. And so we take 5 plus 18 plus 1, and we end up with 24 electrons. So let's take a look. Which of these two is the least electronegative element? It's going to be nitrogen. And so we're going to place nitrogen at the center here. So let's go ahead and place nitrogen at the center. It looks like it's bonded to 3 oxygens. So we'll place 1 here, we'll place 1 here, and we'll place 1 here. So we've just used up 2, 4, 6 electrons to draw our skeleton structure here. So we'll subtract 6 electrons, and that's going to leave us 18 electrons left over, making sure that we satisfy the octet rule for each one of these atoms. So we have 18 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we've used the remaining 18 electrons. Let's see if this works. If we take a look now, remember this is a polyatomic ion, so let's put brackets around it and put the charge. If we take a look, this oxygen has 2, 4, 6, 8, so it's happy. This oxygen has 2, 4, 6, 8, it's happy. This oxygen has 2, 4, 6, 8, it's happy. Looking good so far. Look at this nitrogen, it only has 2, 4, 6 surrounding it, but it wants 8. And so we've used up all of our 24 electrons here. However, the octet rule is not satisfied for each one of these atoms, so this is going to be the incorrect Lewis structure. So what are we going to have to do to make it right? Well, let's take a look. What if we put a double bond between nitrogen and one of our oxygens? We've just used up 2, 4, 6, 8 electrons now. 24 minus 8 is 16 electrons left over now that we're going to have to spread around these atoms, making sure we satisfy the octet rule for each one of these. So let's do this. We've got 2 electrons surrounding this oxygen, plus these 2, that makes 4, 6, 8. Right? So we've just used up 2, 4, 6 of our electrons here. That leaves us with 10 left over. So we're going to use 1, 2, 3, 4, 5, 6 right here. That should leave us with 4 electrons left over. So where are we going to place these 4 electrons? Well, if we take a look here, this nitrogen has 2, 4, 6, 8 electrons surrounding it now, so we don't need to place 2 up here. However, this oxygen only has 2, 4 surrounding it, and it's going to need 4 more electrons. And so, if we take a look at this Lewis structure right here, this should be our correct Lewis structure for nitrate. Let's count them up. We had 24 valence electrons total, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24 valence electrons have been used up, and every one of these atoms satisfies the octet rule. This oxygen has 2, 4, 6, 8. This nitrogen here has 2, 4, 6, 8. This oxygen 2, 4, 6, 8. And this oxygen here 2, 4, 6, 8 for a correctly drawn Lewis structure. So we can see we have a double bond between this nitrogen and oxygen right here. Alright, so those are some medium level Lewis structures for you. Hopefully you'll get the hang of it. Practice away and you should start to get the hang of it. If you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I hope you guys found this helpful.